Hey everyone, so today we're gonna have a look at this problem, Leetcode 560, and in this one we are given an array of nums and an integer k, and we have to return the total number of subarrays whose sum equals to k. Right. So in this scenario, we have two subarray where the sum equals to 2. I mean, of course we can have this one and then this one, but we can't have the one that extends all the way to the end, because then the sum is going to be greater than 3. Right. Okay, so let's explore our approaches. So first one would be that we can do it using the brute force approach, in that the smallest size of the subarray that we can have is this one, right? And then we can extend to this one and then this one, right? And then we can use this one index as a starting point and ending point, and then this remains the starting and ending. So you see, in the systematic manner we are exploring all the options. Our last subarray that remains is this one. So how many subarrays did we generate that start at 0 index, right? We got 0 index, we got 1 index and the 2 index. So for this index we got three subarrays that start at this index. So 3. And what is the n in our case? Like the number of the input, size of the input, that's 3. So basically we generated n subarrays. For this one we generated n minus 1, so 1 less than n. Okay, and then we generated 1. So what does that tell you? Well, that tells you if I were to find the total number of subarrays, that would be n plus n minus 1 plus, of course there would be some middle terms here if n is larger than 3, so but it's gonna get to 1. So this is the series that we have. Now we can find the sum of this one. Now how many terms do we have here? Well, by the way, the formula for the sum of the series is this one. So now n is number of the terms. How many terms do we have? It's n, because it starts with 1, goes all the way to n, so we got n terms, and a represents the first term, so that would be 2n. Then we have n again minus 1, and what is the common difference? That is minus 1 in this case. So let's solve this one, see what we are left with. So I mean, this is gonna give us n plus 1. So of course when we expand this one, it is going to be n squared, and ignoring the less significant term, the complexity is going to be this one. Now this is the number of sub arrays that we have. Okay, so these are the number of sub arrays that we have. Okay, now for each of those subarray, in the worst case, the time to copy that subarray, what would be the cost of copying that subarray? In the worst case, that would be n, because that is like the maximum size. So if it takes one subarray of n to copy, in the worst case, what would be for of n square? We just gotta multiply this, and that leads us to n cube. So this is going to be the time complexity for the brute force method, where we are generating all the, so there are two things happening. We're generating all sub arrays and we are copying those, right? So these are two things, and this is the cost for that, right? Obviously this is not feasible, so let's get back to the problem and see if we can improve that somehow. Well, there is a prefix sum technique that we can do. Let me explain that. So let me just rewrite this problem here. Or uh, rewriting is fine. So k is equal to 2. Now, as we discussed, the subarrays that we're looking for are these. By the way, did you notice that we have only these two subarrays, and how many extra comparison we are going to have to do here, right? So obviously for that reason, it is not really the best method because we are checking for so many things, and out of that only two, subarrays match. That's not feasible. Anyhow, so let's say we are here, right? Now, if we were to maintain the cumulative sum in a variable, what would that look like? So at this point, that variable would have value of 1. Here it will have value of 2, and here it will be 3. And let's say when this is 3, now how can we use this cumulative sum to determine whether the subarray of this size exists? Because this is something that can be done. Well, we have cumulative sum, this is the total, and now we want to say, let's say we want to detect this one, right? Now how would we detect this one? The size of this thing that we want to detect is k. So that means if this is cumulative sum, then the part that is here, that would be cumulative sum minus k. And what does that tell us? This part is everything that is except k, other than k, because that's what the minus actually does here, right? So basically, when we have the cumulative sum, we need to check whether this thing exists here. If it does, then we have found our subarray. So that's how we indirectly know whether we have found our subarray or not. Now, of course, we have to check whether we have seen this uh, first or not. Now, how do we do that? Well, for that we use the map. So in the map, we'll save the cumulative sum up to this point at every point. So first time we're gonna save 1, then we're gonna save 2, but then the question is, and then we're gonna save uh, well 3. No, we're not gonna get to 3 at this point. So first we're gonna save 1, right? And then we're gonna save 2, and when we are here at 3, because this iteration has not ended at this point, we are looking for what? We are looking for 3 minus 2, so we're looking for 1. We're looking whether 1 exists or not, right? Now if it does exist, then we are going to, when we store this cumulative sum, we are also going to store the frequency, and I would explain later why is that. So anyhow, so we got the cumulative sum, and then we got the frequency, and now we are looking into the map and we found the frequency. That means we have found at least one place where this condition is true, and as I earlier said, this is the prerequisite for this thing to exist. So if this now exists, that means we have found a subarray. That means at this point we need to increment the counter variable that we would have. So we need to increment from 0 to, it would go to 1. Why? Because we have found the one condition for the existence of subarray. But then the question is this possible that we would have more than one subarrays with the same cumulative sum? And yes, that's a possibility. In that case, we would have this thing at 2 or 3, right? And then we're gonna take this number and increment the counter according to this frequency. So basically we're gonna take this frequency and add it to whatever we have in the counter. And why is that? Because we're saying now we have found three such sections here where the cumulative sum is what we need, right? So if there are three, then correspondingly we should be able to make three subarrays, and I'll demonstrate that with an example as well. So the example that I have is this one. Now what's gonna happen here? Let's say the value of k is 2, right? So this is the array, and let me just draw the cumulative sum here. So at this point we 1, and then at this point this would also be, notice how the subarray earlier in the consideration was this, now it has expanded to this, but the cumulative sum remains same. Now because of that, in the map the frequency at first would be 1, but then it will go to 2, right? And when we get to this part, it's going to be 2 and then 3. So when we have 2, so we have 2 cumulative sum with 1 frequency and 3 cumulative sum with 1 frequency, and you can see the same thing from the diagram as well, right? So 1 is occurring twice, that's why the frequency is 2. Now what happens when 1 occurs twice? Well, at that point we have two subarrays here. So the first one would be this one, and the second is this one. Both of these subarrays would have sum equal to 1. And as we earlier discussed, 1 is the prerequisite for what? For our requisite subarray to exist, which is this one, right? So when we are considering this subarray, then the other subarray in question would be this, right, the requisite one. And when we are considering this subarray, the other would be this. But you see, in both of cases, this, the sum remains 2, and in this one as well, because we have a 0, the total sum remains 2. So that's what I wanted to demonstrate here. And then there is another edge case we need to take care of. Or rather there is, so we have discussed this, we have discussed this, and there is this edge case. So well, how would, with this logic, how would we detect this one? What happens to this? So let's say at this point the prefix sum is going to be 2, and the k that we're looking for is also 2, so that would lead us to 0. Now 0 means 0 is not something that exists in the map, right? So this pair would be, this would be ignored, because this is not, we're not able to find cumulative sum minus k in the map. So in order to address this issue, Whenever we create a map, we're gonna put 0 with 1. And what that does is anytime cumulative sum minus k leads to 0, then we'll have a 1 already there, and which would mean that because the cumulative sum itself here was equal to the target subarray, that's why we don't need to minus or get rid of some chunk that was here, right? So at that point, will this logic would map to 0, and through that we'll access this. Now what would that do? Then we will make use of this frequency and increase the counter by 1, so it will go to 2, right, if it was at 1. Well, there is another edge case. That would be, let's say we have 1 and minus 1, and then we have 0 and k is equal to 0, right? Now in this scenario, the prefix sum here is 1, then it goes to 0, and then it is also 0 as well here. Now what would happen here? Now if you notice, for this one, uh, we would have 1 minus 0, so we'd be looking for 1, but that 1 is not anywhere right before this, so that won't work. So then we'll look for 0 minus 0, and that is also not anywhere. But like we discussed, since we're going to set 0 to 1, right, so this would actually map to um, this because the cumulative sum here is 0 now, and 0 minus k would be 0, and that would map to this. So counter here would be incremented from 0 to 1. Well, this is the first subarray we have found that has sum is equal to 0. Now moving on, the cumulative sum remains 0. Now at that point, we're going to check whether yeah, so whether there is a subarray here anywhere afterwards. So we're going to have like cumulative sum 0 minus 0, and that would lead us to another 0, right? So what would happen here? Well, in this case, I do recall for this scenario, when I read about it, this should have 3 subarrays, right? So the first one would be this. So here is what is going to happen. When it is here, it is going to increment by 1, and then this would be updated to 2 because now we found another 0. So 1 0 was by default, and then we found another 0, and then when we are here, yeah, when we're here and we're looking at the cumulative sum minus k, it leads us to 0, right? So currently we have exactly 2, and that 2 would be added to the counter. So that's how the counter would end up at 3. Now the interesting thing is at no point would this be at 3, right? It would first be at 1 and then it would go to 2. But since we are incrementing this increment by this much into the counter and then by this much, so that's how we would end up at 3 without having 3 here. So that's interesting. So anyhow, this is how this case is handled, and yeah, that's pretty much it. And I think at this point we should just code this one. So first thing first, we are going to need a map. Well, I was just thinking, why not just code in the editor instead of this one? I mean, we have done all the dry run, so perhaps no need to type the whole thing.